Greetings all, hope you all are doing well. So today we will start our new topic called atomic structure. First of all, we should know that what the atomic structure is. The word atomic, A means not and atomic mean to cut. So the word atomic means not to cut, or you can say that a non-breakable. After talking about structure definition is position or location of atomic particle in space is called structure. Okay, atomic means not to break or not to cut, and structure means to position or location. After that, there are more than 100 subatomic particles, but there are just only three fundamental of particles. Number one, electron having negative charge, proton having positive charge, neutron having no charge. In previous lecture, I told you that why electron, proton, and neutron are having negative, positive, and no charge. And talking about collectively, particles of proton and neutron are called nucleons. Are called nucleons. After that, our main topic is about discovery of electrons, because we have started our new chapter, so we are having discovery of electrons. How electrons is discovered, we should know this first. Discovery of electrons. So first of all, we should know the name of scientist, that who was the scientist, name of scientist. After that, we should know the name of experiment, that what this experiment called. After that, we are having name of device, or you can say instrument by which this experiment has been done. Device या instrument. Okay, these three things we should know. So talking about name of scientist, the name of scientist was William Crookes, or you can say just William Crook. William Crook was a scientist who discovered electrons, and the name of experiment, experiment name was electrolysis experiment. What kind of experiment is it? It's called electrolysis. It's electrolysis experiment that done by William Crookes. Now name of the device or instrument. So as a William Crook discovered the electrons, so the name of, you can say, device or instrument will be Crook. You can also say the Crook tube, or you can say Gessler tube. Gessler tube, or you can also say discharge tube. It's also called discharge tube. According to our previous book, there is written discharge tube. So Crook tube comes from the scientist Crook. Gessler means to the instrument maker. Gessler means the instrument maker, and discharge means that the free of charges. It's called discharge tube. After that, our main topic is name of experiment. So what was the name of experiment? That the name of experiment was electrolysis. Now what should be the definition of electrolysis? The simple definition is that a passing current through low pressure of gas is called electrolysis. Now we should do the experiment with model of discharge tube. Just wait, model of discharge tube. We should do experiment Now what should we do? That first of all we will take a long glass tube, or you can say we will take a discharge tube. Long glass tube or discharge tube. Now I am just putting a picture over here. Just wait for that. If I am having an option. Okay, so now we have taken discharge tube over here. Now I will show you that how the experiment happens over here. First of all, as I told you in electrolysis, that we should have that we should have a low pressure. But what happened, here is a high voltage generator. It can be 5000 volt to 10,000 volt. So what happens, we are having our discharge tube, in which here we are having cathode. This is our cathode having negative charge. This is anode having positive charge. Okay, and between there, here is a gaseous molecule. You can say here is a gas. Okay, now what we have to do, now what happens over here, that now here will be one option we are having, that whenever, just wait, that when this minus goes to here, but there is not a low temperature, there is a high pressure, sorry, not a low pressure, so it not move forward. Okay, but what happens, we are having here a vacuum pump. What we will do, low down the pressure of the gas from this vacuum pump. When we do that suction pump, you can also say the suction pump, when we vacuum push the vacuum pump, the pressure will be low down, and this low pressure moves into the cathode rays, in the form of cathode rays in a gas. And what it will do, that it will be shiny. Like at ordinary pressure there is no conduction, but at lower temperature it clashing, and then it's glowing and bright. Like it will spread a light over here inside this one. Okay, and after that what happens, that when we are having a pressure at 0.01 torque, we are having that much pressure. So what happens, that it will be darkened, and there will be not any kind of a glow when it will be 0.01 on a pressure. Then it will be on that much pressure, so there will be no glow of light. After that what happens, that William Crookes watching this one, you can say discharge tube, that where light goes, so light goes at the behind of this anode, and it glow into a green color. Okay, so after all, that glow move to the end, or you can say the behind of the anode, and it's called the cathode rays. What it called cathode rays. Actually, why it called cathode rays, because we are having negative charge over here. So that's why this all process in a long glass tube, discovery of electron, is called cathode rays. Now we should move forward to the properties of cathode rays. So there are two properties of cathode rays. One is electric field and second is magnetic field. In electric field, what happens, that if it affects on charges, I will tell you how. And it in the magnetic field, it affect on mass. Now how it will affect on the charges, actually what happens, that in electric field, this is a electric field ray. When the ray comes from here and move downward, it's making a circle over here, it's a positive, and it moves to the negative side. and we are having here electric field in a cathode rays. There's a one, this is called a one property of electric field. After that, second property of electric field is that second property of cathode rays is magnetic field. What happens it over there, that there's a same cathode rays, we are having cathode rays over here. When it will come down, its make a position south and north, and when it will goes to the north pole, it means it we are having mass in a magnetic field. And if it will be not going, it will be going just in a straight line, so it means there's a no mass and no any effect of mass on magnetic field of properties of cathode rays. After that, this deflection of magnetic and electric field in a cathode rays have the ratio of both. What the ratio is? The ratio of both is E upon M. Now what E upon M is? E, we are having E is equal to charge. This is we are having charge. After that, M is equal to mass. So one thing, that deflection of magnetic field and electric field in cathode rays is the ratio of both. It deflect with the charges and masses. In cathode rays deflection, there should be the ratio of charge and mass, then it's called the deflection of magnetic and electric field cathode rays. So I hope that you understood today about the model of discharge tube and our main topic of atomic structure. In atomic structure, we have done our fundamental particles, discovery of electrons, and model of discharge tube. Hope you understood. Thank you so much.